over phone. And it's like this thing. Off my rant because I'm recording. Won't be on YouTube going on a rant, that's for sure. Okay, so I want to go over the Boehringer questions because they're rather difficult for a Friday. And mostly because I'm a little confused on number 2, so I wish someone could give me a little insight on that one because this kid in first period has me convinced I'm wrong, but I don't think I am wrong. I think he's making it too easy. Maybe someone has a mathematical argument better than mine and his. As for number 1, does anyone know the answer? It is not E. It is not E. It is not A. But then we're just going down a list and random things. You said B? No, I thought it was C. I'm fairly certain it's C. Does anyone know a way to actually solve this problem? I appreciate the honesty. Does anyone know a way to actually solve this problem? What can we normally do in math class in a multiple choice thing? We could guess. What else could we do? We were given answer choices. What should we do with those answer choices? Plug them in. So you could go down the list and plug in each of them. So you could do 8 and then 2 and negative 1/3 plus 1. See what number you get. And you could do 4 and 1 minus negative 1/3 and see what number you get. And if those numbers match, then that's the answer. If those numbers don't match, then that's not the answer. But that requires you to be a bit meticulous, and most people aren't, so that might not be a good idea. I'm going to show you a different way that involves bases and exponents. Just as a reminder, this is something you learned in algebra. The big number on bottom is called a base. The tiny number up top is called an exponent. We would love in this problem if they could have the same base. If they have the same base, then we can just set the exponents equal to each other. So for instance, I know 8 is really 2 to the 3rd. So I'm going to rewrite 8. Instead of writing 8, 2x plus 1, I'm going to have 2 to the 3rd, 2x plus 1. I'm substituting in 2 to the 3rd for 8. What could I sub in for 4? Don't guess anything silly. It's not the day. Oh, give me a for real one. You could for real do this one. I know, I did. I agree. I appreciate you trying to make me in a happier mood. Can someone help me? I need to have the same base as the other. What can I put in place of 4? 2 to the 2nd power, because 2 to the 2nd is the same thing as 4. Perfect. Thank you. Okay, since we have the same bases, they both have base 2s, we can stop writing the big 2's and just start writing the exponents. But before we do that, I have a question. When do you add exponents and when do you multiply exponents? We need to recall our rules of exponents. Okay, so x to the 2nd times x to the 3rd, what do I get for that answer? Is it x to the 5th because I add, or x to the 6th because I multiply? X to the 5th because you add. When you multiply, you just add the exponents. When you're raising a power, you multiply the exponents, so you would get x to the 6th. So in our case, are we multiplying or are we actually raising a power to a power? Thank you, dear. So we need to multiply. So 3 times 2x plus 1, very good answer. And then 2 times 1 minus x. When you distribute, you get 6x plus 3 equals 2 minus 2x. And this sounds like a lot of work. And so those who wanted to just plug in might get to the answer a little faster than I am. I'll have 8x plus 3 equals 2. That's wrong. What have I done wrong this time? I did something wrong last period. I'm doing something wrong this period. It is just not. No, it's not wrong. Okay. Good gravy. So I get 8x equals negative 1. So x equals negative 1/8, which is C. I understand most people don't know to do that. You did exponents last year, but not that many problems like this. But at the beginning, we were just guessing answer choices. If we were just guessing answer choices, I wouldn't have guessed D or E because they were both positive. I would have guessed A, B, or C because they were both negative. They were all negative. And then, you know, I like to look for a pattern. I see the 4 and the 8. So I was going with either B or C when I was guessing. And then we get to the one that's driving me crazy today. You would think number 2 would be awesome because it looks like geometry. It's triangles. I love triangles. Yet I'm mad at it and I'm stuck on it. And I need your help with it. Okay, remind me what's the formula for area of a triangle. Base times height, and then what else?
Oh, no.
That's,
Base times height divided by 1/2.
yeah, so you can either do 1/2 base times height or base times height divided by 2. I'm the old school 1/2 base times height, but base times height divided by 2 is the exact same thing. You can't see what I'm writing. Either they're equivalent. Okay, so we got to figure out a base because we need to plug that number in. We got to figure out a height because we need to plug that number in. I can figure out one of them. Pretty easy. The base would be this distance. So I said from 1 to 5 was length 4. So I wanted to say that the base was 4. And then I was stuck on figuring out the height. And I tried last period to do like the distance formula of AB. If you wanted to, I believe I got square root of, here I'll have to look at my old bell ringer. I got square root of 5 when I did the distance formula on that side. I got square root of 13 when I did the distance formula on that side. But I don't see how calculating the lengths from A to B and the length from A to C, I don't see how that's helping me solve this triangle. So, that's how I got stuck. I know things. I'm just trying to use things that you and I have talked about, not things you and I are going to talk about in the future. I had someone last period try to argue that since this is at 3 on the y-axis, because you see it's 1, 3, and then we go up to 5, that technically this is 2. So they're trying to argue that the height is 2, so it's 1/2 4 times 2, which is 1/2 of 8, which is 4. So they're arguing it's A. That just seems too easy. I think there's something wrong or flawed in that argument, but I don't know. My brain is not mapping today for some reason. What would I have guessed?
Either B or C.
And why would I go with B over C? Yes, because of the root 2. Notice the root 2's kept happening. Notice the 4's kept happening. So the one that has a 4 and a root 2 is the one that I bet is the answer choice. But do I have the math to back up my assumption? No, I don't, because I'm having a day. So if you can figure it out before Monday, please let me know. Otherwise, I swear I will have it by Monday, because, you know, it drives me crazy when I can't figure things out. Okay, the notes from yesterday. There were a couple words we wanted to remember. Ratio and proportion. Okay, so what I want to do today is finish up the notes and then let you work on your worksheet. But I also have a checkpoint quiz. If you recall, that's the one that drove Katie crazy last time. That's where everyone's going to make 100. I call you over to me, you take it. You stay with me until you get the 100, the 10. It was you, Addison. You remember, it drives you crazy, but everyone's going to get a perfect score in that 30% category. So everyone wants that. It's just the work that's the problem. Yeah, it's only 3 problems. It won't take long. But I would tell you as a hint to you that last period struggled on, I have one problem that involves an extended ratio. It looked like either 3 or 4 that we went over yesterday. And I had to remind them how to set it up, and I refuse to remind you because you're too smart for that. Plus, I'm giving you this beautiful hint to read over 3 and 4 before I call you to me. One of those days. Okay. So we talked about ratios yesterday. You know, I want it as a fraction. I want it in simplest form. We talked about proportions and cross multiplying. We all seemed great at that. We've just got to finish up the bottom of the notes. Again, this is probably it'll probably be your favorite chapter because it's pretty easy and it's actually real world applicable. The only reason you won't like it is because it makes you read, because most of the problems, since they're real world applicable, they're word problems. Okay, I'm tired of talking. Nick, will you read number 8?
If the ratio of boys to girls at a high school is 4 to 3 and there are 936 boys, how many girls are at the school?
Okay, so we need to actually set up a proportion so we can cross multiply and figure out how many girls are at the school. What needs to go in the numerator? Boys or girls? Boys. It says boys to girls. I always write that to the side. That way I make sure I'm doing the right thing. Because sometimes they trick you, and instead of saying boys or girls, they'll give you the total. And you would have to subtract the boys to figure out how many girls there were. Like they might say there are 10 people in the class and 7 are boys. And what's the ratio of boys to girls? Well, then you would have to, 10 minus 7 is 3. There are 3 girls. Boys to girls would be 7 to 3. You can see how they would trick you. This is me giving you another hint for life. Okay, getting back on track. Nick read that there are boys and girls. What number needs to go in the numerator? 4 or 3? 4. So 4 over 3 equals, and then where do I put the 936? In the numerator or the denominator? In the numerator. Okay, so again, it was boys to girls. That's how I knew it was 4 to 3. Boys came first, then girls. And this one even says boys. So 936 goes in the numerator. What do I put in the denominator? X. When I don't know what to do when I'm solving, I put an X. I cross multiply and I get 4x equals some number. So 4x equals 28. I thought it was 2808. Is it not? Somebody multiply. Okay. I thought it was 2808. And then, so when I divide by 4, I get x equals 702?
Yeah.
Okay. So how many girls are at the school? 702 girls. Are there any questions about that? So we all like the cross multiplying part. We're good with that. But the difference between this problem and what we did on 5, 6, and 7 is now Addison has to be a big girl and she has to set up her own proportion to then cross multiply. So if she can't set it up, she's never going to cross multiply and solve, and then she's stuck. Okay. So I don't recall if we talked about this yesterday or not, because I'm telling you, when you're hot, you're hot. When you're not, you're not. This is a scale model of a town. This was someone's city project. Obviously, a real city would not fit in my hand, but you have to admit her ratios seem pretty good, like how big her houses are, how big her streets are. It's not like the park is taking over the whole city. So we have a scaled down model of a city, and you always see I have my Eiffel Tower normally over there, but I have a Eiffel Tower. It's a model of an Eiffel Tower. Obviously, it's not the same dimensions as the real one. It's not as big, but hopefully it has the same scaled down properties. I assume the real one has all the same features. So when we need to make models like this, and we need to be consistent with like our side links and everything, we would need a scale factor. You may. And I've left my highlighter somewhere, but if I had it, I would highlight that word, scale factor. That is an important word. So the scale factor lets us know how to go from the real Eiffel Tower down to my mini one, or vice versa. It helps us keep the proportions realistic. Okay, and I always put the model in the numerator and the actual, like, so the model Eiffel Tower, the pink one, in the numerator, and the real Eiffel Tower in the denominator. And then the most important words of wisdom are the ones in the last sentence that say, make sure you are using the same units before you reduce the fraction. So if you're given meters and centimeters, you need to put them both in meters or both in centimeters before you start doing any calculations. You've got to be the same units. Okay, Hazel, read number 9, please.
Miniature replica of a 1923 checker cab is 6.5 inches. The actual length of the car was 13 feet. What is the scale factor?
Okay, so again, I always do the model in the numerator and the actual in the denominator. When someone asks you specifically in the problem for a scale factor, there's a difference to me in a scale factor and a ratio. I'm not going to cry on a scale factor if you give me the decimal. Especially like in the problem Hazel read out, it's already in decimals. So I can't be mad if your answer's decimal. Okay. Before should I put 6.5 in the numerator and 13 in the denominator? No, why? Gotta convert feet to inches first. They're not the same units right now. That's inches. I need inches. So I need to multiply 13 by what number? 12. So 13 times 12 is... Okay, so I have 156 inches. So the model, which is the little tiny cab, is 6.5 inches. The real one is 156 inches. So Alex can either type this straight in his calculator like that, or if he would rather, change it to 65 over 1560 and actually try to reduce that fraction, that's fine too. But I'm just going to go straight to the decimal today for once. Somebody have it typed in. Okay, 1/6. So I'm going to do 0.042 because I only went 3 decimal places today. Okay, notice because we're putting the model in the numerator, it should always be a decimal that's less than 1. That's your hint. Okay, and then our last problem says, I'm going to do model in the numerator, Ashland in the denominator. Elena, can you read 10?
If a map scale is 1 inch equals 50 miles, and the distance on the map between point A and point B is 3.5 inches, how many actual miles apart are point A and point B?
Okay, so in this one we're actually going to need to set up a proportion. So I know 1 inch in the model is actually 50 miles in the actual. I know we just talked about converting, but if you set up a proportion where inches are both in the numerator and miles are both in the denominator, that's actually allowed. And then we have 3.5 inches between A and B, and we need to know how many actual miles there are. So we set it up. Are there any questions about how I set that problem up? I was told 1 inch and 50 miles right there. They told me the model was 3.5 inches, so how many miles is it? Hence why I put an X. When I cross multiply, I get X equals some number. Say it again, Toby. 175, so 175 miles. Okay, so let's think that through. Most of us are spoiled, like me included, in that we use our GPS, so we never actually have to think this through. But our parents actually had to read a map, and so they would see how far something was on the map, and they would actually have to use this kind of a scale to figure out, okay, it's 3.5 inches, how many miles is that going to be for our trip? Because you got to figure out, do I have enough gas? Do I have enough food for the kids? Did I bring enough formula? That kind of thing. So this problem is probably irrelevant for us, but was very useful for them. Okay, get out your worksheet. You would love to